In our previous lessons, we've been working on solving systems of equations in a variety of formats. We've been working on solving them graphically and algebraically by substitution and elimination. We've also been practicing writing different systems of equations to model a variety of situations given to us. And so we're going to be doing that again today. Based on the situations given, we want to see if we can write a systems of equations to use to solve, and also determine what might be the best method to use to solve that system of equations, whether it's graphing or algebraically by substitution or elimination. So here our first problem, the band is putting on a concert to raise money for AIDS education in Africa. Students must pay $2 for a ticket and adults must pay $3 for a ticket. A total of 300 tickets were sold and a total of $712 is raised. How many student and adult tickets were sold? Well, typically in problems like this, we always suggest underline what you know and circle what you want to know to help streamline the pieces that you may use for your equations. We also want to think about what are kind of the main two topics that are being discussed. And those two topics, what we can do is look for hints as to totals that are going on in our problems. So if we look at our givens here, we can see that they're discussing a couple of totals in our third sentence. It says we have a total of $712 being raised and a total of 300 tickets. So we know kind of the two topics or two equations would have to involve those two totals. One would represent the number of tickets and one would represent the number of dollars that are being raised. So when we talk about tickets, well, what kind of tickets are being sold? We know that we have student tickets and we have adult tickets. Talking about money that's generated from the tickets, students pay $2 and adults pay $3. We need to know how many students and adult tickets were sold. So this is what we want to know. So I'm going to circle that. That's our end result. So the unknown pieces are students and adults. So why don't we use those as our variables? Why don't we say let S represents the number of student tickets sold and A represents the number of adult tickets sold. So we're defining our variables. Now we should be able to start writing the equations that we were discussing with these variables. So we said one equation has to represent the total money raised, the dollar amount. So we know we have to have something equal to $712. Well, where is that coming from? $2 for students and $3 adults. So 2S plus 3A equals 712. The other we were talking about was the number of tickets. So student tickets, S, and adult tickets, A, equal 300. So we have our two equations for our system. As we look at these equations, what would be the best method to solve? Graphing, substitution, or elimination? Well, if we were doing this by graphing, S and A would have to correspond with X and Y, and we'd have to take each of those equations and put them into slope-intercept form to either graph by hand or use the technology to help us. By the time we did all that, we could do some algebraic solving, so that probably is not the best method graphically. Algebraically, your options are substitution or elimination. Substitution, you're looking to see, do you have a variable already isolated? So for us, do you see an S equals or an A equals right away? We don't. So maybe we want to eliminate one of the variables. So for this problem, I would suggest doing elimination because we could multiply one of the equations by a value to make the coefficients the same integer, but one would be positive and one would be negative, because when we eliminate, we add the equations together to make a zero. So why don't we take the second equation and let's work on eliminating S. So let's multiply the second equation by -2. And in doing so, we would now have -2S minus 2A equals a -600. And again, the goal is to add the equations together to eliminate a variable. Well, 2S and a -2S is 0. 3A and a -2A, well, that's just A. And 712 and -600, that would be 112. So A, the number of adult tickets, is 112. But not only do we need to know the number of adults who have to attend, but also the number of students. So we're not done just yet. We're going to take the value for the number of adult tickets and substitute it into one of the two original equations to find the number of student tickets. And that second equation would be perfect for that because there's very little calculations that need to happen. When we substitute in the value for A, now we just have to undo the equation by subtracting 112 to get the number of student tickets, which is 188. So we know exactly how many of each type of ticket would have to be sold to get the funds raised. We know that we need 112 adult tickets and 188 student tickets to be sold in order to raise the $712. Let's take a look at another scenario. The number of calories in a piece of cake is 20 less than 3 times the number of calories in a scoop of ice cream. The cake and ice cream together have 620 calories. How many calories are in each? So what do we know about the problem? We can see that we're talking about calories in cake and calories in ice cream, and we keep going back and forth about cake and ice cream. So we could have those represent our variables because our goal is, again, to figure out how many calories are in each, the slice of cake and the ice cream. So let's start defining our variables. Let's say C represents the number of calories a piece of cake has, and H represents the number of calories in a scoop of ice cream. Now we said try to go and look for totals. So as I go to look at my sentences, what kind of totals do I see? Well, the first equation says the number of calories in a piece of cake is, and is our clue about a total. Whenever we see is, remember that's an equals, okay? So it's going to kind of tell us. It says the number of calories, so that's kind of what we're ending up with, right? The calories is the total. 20 less than, well, 20 less means we're taking away 20 from something. 3 times the number of calories in a scoop of ice cream. Well, we know the scoop of ice cream calories is H. We want 3 times that amount, so we'd have 3H. And so these two items together is making up the total calories for our cake. So we have one equation right here, talking about the total calories in the cake. Now, what else do we know? Well, it says the cake and ice cream together have 620 calories. We'll have here, there's another clue about a total, right? It's equal to 620, and where does it come from? Cake and ice cream. Well, the number of calories in the cake is C, and the number of calories in ice cream, that's the H. We've got another equation here. So these are two equations that we came up with. C equals 3H minus 20, or if you wrote it as negative 20 plus 3H, it's the same thing. And C plus H equals 620. Again, looking at this, what would be the best method? Like we said in our previous example, graphing would not be best for this because it would take a lot of work to put them into graphing format. So would substitution or elimination be better? Well, by looking at our equations, we can see that we have a variable isolated already, C. So if I know what C is, I could take that and substitute it into the other equation. So substitution would be perfect for this situation. So if we take C from the first equation and substitute it into the second equation, what's going to happen? Well, now we'll have 3H minus 20 plus H equals 620. And notice how we need to simplify the left-hand side of our equation. So we have some like terms to put together. So 4H minus 20 is equal to 620. We're going to continue undoing the equation to solve for H. So we're going to add 20 to each side and then divide by 4. So H equals 160 calories. That represents the number of calories in the ice cream scoop. But we also need to know how many calories are in a piece of cake. So that first equation would be perfect for this because the cake was already isolated. If we substitute the number of calories in for the scoop of ice cream and follow your order of operations, we can see that a piece of cake will have 460 calories. So what have we learned? In summary, a piece of cake has 460 calories and a scoop of ice cream has 160 calories. How about this scenario? Slam scored 5 points less than twice the number of points scored by Dunk. Together, they scored a total of 43 points. How many points did each player score? So we want to know how many points each player scored. So we're going to circle how many points. That's what we want to know. What do we know? We're talking about two players, Slam and Dunk. We don't know how many each have, so those would be perfect for a variable. So why don't we say S is the number of points Slam scores, and D represents the number of points Dunk scores. Can we come up with some equations based on our givens? So we suggested looking for totals. Well, it says Slam scored 5 points less than twice the number of points scored by Dunk. Slam scored, so this is talking about his total. 5 points less means you took away 5 points, then twice the number of points scored by Dunk. So 2 times whatever Dunk scored. Those two items gives you the total for Slam. Now, together, well, who's together? Slam and Dunk scored a total right here of 43 points. So it looks like we've got our two equations. S equals 2D minus 5, and then S plus D equals 43. So how many points did each player score? Well, what would be the best method for solving? Graphing, substitution, or elimination? Looking at your equations, we can see, and a variable is already isolated. Therefore, substitution would be the best method for solving this problem. We can take what S is equal to in the first equation and substitute it into S for the second equation. That would look like this. 2D minus 5 plus D equals 43. We have some simplifying to do on the left-hand side of our equation. So we have some like terms to combine. We have 3D minus 5 equals 43. Now continue undoing to get D alone. So add 5 to each side and divide by 3 on each side. D equals 16. Dunk scored 16 points. How many points did Slam score? Well, if I take my value for D and put it into D for the first equation, I can figure out how many points Slam scored. Continue with your order of operations. We know 2 times 16, well, that's 32. If we take away 5 from that, that's 27. So Slam scored 27 points, while Dunk scored 16 points. Let's try one last one. A shipment of laptop computers weighs a total of 136 pounds and contains some laptops that weigh 5 pounds and others that weigh 8 pounds. A total of 20 laptops were shipped. How many lighter laptops and how many heavier laptops were shipped? Well, what do we know about the problem? We're talking about two different types of laptops. A 5-pound one and an 8-pound one. So if we're talking about lighter and heavier, lighter would refer to the 5-pound one because that's less than the heavier 8-pound laptop. So since we keep talking about those two types of laptops, we can kind of start identifying the variables. Why don't we say X represents the lighter 5-pound laptops and Y represents the heavier 8-pound laptops. Could we start generating some equations then? And we said look for totals, right? So what do we know about totals? We have a total of 20 laptops that were shipped, right? Here's our total. We know something equals 20. Well, what made up that 20 laptops? That was from the 5-pound and the 8-pound, right? So we know however many 5 pounds, we said X, and however many 8 pounds, Y. That gave us a total of 20 that were shipped. Now we have another total here of 136 pounds. So I need something that equals 136. We're talking about weights, right? Well, where else do we see weights? Here and here. So we said there are 5-pound laptops and 8-pound laptops that were shipped out. It appears we have our two equations that we could use to solve our system. We've got x plus y equals 20 and 5x plus 8y equals 136. Well, what would be the best method to solve this system of equations? For this one, we can see that we could do this by graphing if we wanted to take the time to isolate y and put it in slope-intercept form. Probably would be a lot of time and work involved in that, so not the best option. We could solve it by substitution if we took the first equation and isolated one of the variables x or y and substitute that way. But again, that would take some work to do that. Personally, I would say elimination would be the best option because there is a value we could multiply the first equation by, so that when we add the two equations together, we would make a 0 and only have one variable to solve for. So what we're going to do is take the first equation and let's multiply it by a -5. That way, when I add the equations together, the x's will make a 0, and that was our goal. So by multiplying 5 through on the first equation, -5 I should say, we have -5x minus 5y equals a -100, and we want to add that to our second equation, 5x plus 8y equals 136. Well, by adding them together, we're left with 3y equals 36. To get y alone, we would divide both sides by 3, and therefore y equals 12. We also need to know what x is because it's the number of each type of laptop we're interested in. So if I know y, I could take it and substitute it into the first equation and solve for x. So to get x alone, you would subtract 12 from each side. X equals 8. What does this tell us? Well, x represented the lighter laptops, the 5-pound laptops, and y represented the heavier laptops, the 8-pound laptops. So if you want to do your summary in terms of lighter versus heavier, you could write 8 light laptops were shipped and 12 heavy laptops were shipped. You also could talk about it based on the weight. 8 5-pound laptops were shipped and 12 8-pound laptops were shipped. Both of those would be correct summary sentences. So now it's your turn to practice with the scenarios given to you. Can you identify the two variables that are being used to write a system of equations to solve to find what makes that scenario true? And again, think about the options that you have for solving. Do you want to use substitution or elimination for algebraic means, or would you want to take the time to graph and find the solution that way?